Most of us grow up believing something very simple, that Earth revolves around the sun and the sun just sits there, quietly floating in space. It feels comforting, stable, predictable. But the real picture is far more complex and far more fascinating. As we zoom out and look deeper into the universe, we discover that Earth is never still, not for a single moment. Yes, our planet orbits the sun, but at the same time, the entire solar system is dashing through space at an incredible speed, and this motion may be connected to some of the greatest mysteries of the universe. Some scientists believe that as Earth moves through the galaxy, we pass through regions filled with cosmic rays, high-energy particles capable of damaging DNA. These cosmic encounters may have caused genetic mutations, and could even be linked to mass extinctions in Earth's past. Even small changes in Earth's orbit around the sun can affect our climate. Over long periods of time, these changes may trigger dramatic shifts, including ice ages. To understand our future, we must first understand how we move. Relative motion. Why we don't feel it. Imagine you're sitting inside an airplane. The plane is flying smoothly at a constant speed. Inside the cabin, everything feels still. You can walk, pour a drink, even jump, and land in the same spot. From your perspective, it doesn't feel like you're moving at all, but someone watching from the ground sees the airplane racing through the sky. This simple idea was described by Galileo in 1632 and is now known as Galilean relativity. There is no single absolute state of rest. Motion depends on where you're observing from. And Earth is the perfect example. Earth's orbit isn't perfect. From inside the solar system, Earth appears to orbit the sun. But even that orbit isn't a perfect circle. It's an ellipse. Sometimes Earth is slightly closer to the sun, a point called perihelion, around January 3rd, and sometimes it's farther away, called aphelion, around July 4th. These subtle shifts influence how sunlight reaches Earth and help shape our seasons. But here's something even more surprising. The planets don't just orbit the sun, they pull on it too. Massive planets like Jupiter and Saturn have such strong gravity that they actually make the sun wobble. This gravitational tug slightly alters Earth's orbit over time. These long-term orbital changes are called Milankovitch cycles. They affect Earth's tilt, its distance from the sun, and how sunlight is distributed across the planet. Over tens of thousands of years, these cycles can push Earth into, or out of, ice ages. The solar system is spiraling now. Zoom out even further. The solar system itself is not stationary. The sun, dragging every planet with it, is orbiting the center of the Milky Way galaxy. We are located about 25,000 light-years from the galactic center, inside one of the Milky Way's spiral arms. As the sun moves, the planets follow behind, not in flat circles, but in a giant corkscrew pattern, a spiral. The sun travels through the galaxy at about 500,000 miles per hour. Yet even at this incredible speed, it takes roughly 225 to 250 million years to complete one orbit around the galaxy. Earth has done this journey only about 20 times since it formed, up, down, and through danger. The sun's path isn't perfectly flat either. It slowly oscillates up and down through the galactic disk like a wave. One full vertical oscillation takes about 60 million years. Some scientists believe that when we pass through denser regions of the galaxy, Earth may be exposed to higher radiation levels. These passages may correlate with periods of mass extinction in Earth's history. The galaxy is not a calm place, and it doesn't stop there. The Milky Way itself is moving. Our galaxy is racing toward the Andromeda galaxy. Both are part of a larger family called the Local Group. and the local group is being pulled toward a massive, mysterious region of gravity known as the Great Attractor. Even beyond that, the entire universe is expanding. Space itself is stretching. Galaxies are moving farther apart. Using the cosmic microwave background, the leftover radiation from the Big Bang, scientists have measured that Earth and our solar system are moving through the universe at over 800,000 kilometers per hour. Final thought: Earth is not just a rock floating in space. It is part of a vast, interconnected, ever-moving cosmic system. We orbit, we spiral, we drift, we race, all without ever feeling it. And yet this invisible motion